Next up, Dr. Joe Stanley coordinates the computer engineering undergrad program at Missouri S&T. His research centers around computer-assisted tools for domain experts in the decision-making process. But on a lighter note, Joe enjoys playing Pac-Man. He won competitions as a teen, but when his wife bought him a home console during the pandemic, things got really serious.
They did.
Now, if you go to Scruff's Grill in Rolla, you're going to find a plaque or something up there displaying that he's the Pac-Man champion of McDuff's. Now, if you've played Pac-Man, you'll appreciate this. His high score, 190,880, crushing the old record by 30,000 points. Pretty impressive. So now we're going to hear how he's crushing skin cancer detection.
I am not a modern video game player. I grew up in an era where if it's two-dimensional, I'm great, but if it gets beyond that, I have a lot of trouble. I'm so grateful for the opportunity to be here to talk about our ongoing research. What I'm going to be presenting to you today is a currently funded R15 that's a collaboration with Mizzou and also South Florida. And so in looking at this, this is purely undergrad based. We originally started this with, or we had budgeted 4 students. This is only a partial list. We've gotten students from multiple campuses participating. A lot of pre-med students who aren't even part of the system or at South Florida have contacted us and are actually getting involved as far as looking at some of the data. Dr. Stecker, the dermatologist in Rolla, with whom I have worked since '99 on skin cancer imaging, he has mentored over 15 pre-med students. And so getting published as undergraduates, basically getting mentored and ready to be able to apply for med school, that is something that we're strongly interested in doing, and that's really a significant motivation in our project. So when we look at the need for the particular research that I'm going to be describing as far as skin cancer imaging, there's really 3 different facets to it. One, skin cancer is very prevalent, and it's the number of cases, as you can see, a significant number per day. And so with the continued increase as far as skin cancer is concerned, its prevalence, the nice part about it is if you're able to detect it early, fully curable. And so when we look at trying to be able to come up with techniques, one, we want to be able to get to a point where we can look at skin lesions, be able to make some decision. Because there are so many cases, the goal is to try to be confident about them, be able to hopefully stay away from the biopsy side so that we can move on to more problematic types of images or cases. And so in the scope of this, we've looked at, as far as skin cancer imaging or skin lesions are concerned, we've looked at it from the perspective of those who are first in line in seeing people with questionable skin lesions. Looking at the training that's available for them, trying to be able to get in a position where there are tools and resources available for them as far as helping them to become more aware of the different types of lesions that are out there. And so as far as, if I can find my pointer here, I don't want to do something silly. Pointer. Oh, here we go. So as far as looking at the dichotomy that we have people who are first in line who may not have the formal training as far as looking at skin cancer imaging. We also look at a shortage as far as the number of people who are in those positions. And so what we're ultimately looking for are aids that can help in the diagnostic process. And one of those that, as far as the focus of our research, relates to dermoscopy, beginning in around '89 when the dermatoscope was introduced. And so really there are 3 primary focal points as far as our research is concerned. One, as I pointed out, the prevalence of skin cancer and the necessity for early detection as far as being able to treat it. Second, as far as computational resources, it's amazing to see when compared to when I first started to where I am now as far as going from traditional image processing to the use of AI. And so AI has really engulfed or has really become the focal point as far as image analysis is concerned. And so we're looking at being able to take advantage of the capabilities of AI and also take advantage of the capabilities as far as experts are concerned. And so when we look at this, the primary issue that I want to get across here is coming up with resources that can help experts in their training and also researchers related to being able to develop AI-related techniques. And so what we are looking at is a process to be able to compile image data that has been collected worldwide that we can be able to have multiple experts collaborate, be able to identify key features of these skin lesions and do this in a validation type of approach so that these can now be publicly available for both machine learning development and also as training aids. And so the primary issue that we've come across, and I'm sure it's your experience for those of you who've worked with large data sets, a lot of them are proprietary. They're difficult to get to. They're also very expensive to be able to collect. And so we're trying to come across barriers like that as far as coming up with something that's more general purpose. And of course, I just blotted out the screen. As far as our research is concerned, what we want to do is be able to develop machine learning techniques that integrate the expert. So we want the expert in the loop, be able to take a collection of annotated images of different types of skin lesions, be able to use the expert in helping guide the training of the AI algorithms and also maintain explainability. One of the issues that's difficult to overcome as far as AI is concerned, many of the algorithms are nonlinear, meaning that trying to interpret when there is an output that is incorrect, being able to go back and look at where the mistakes originate, that's a real problem. And so we're trying to be able to address that in the types of tools that we're developing. So the research that we are currently doing with this NIH grant is in collaboration with the ISIC, the International Skin Imaging Collaboration. As you can see, this is a very significant data set that, and Dr. Stecker in Rolla has contributed. He was one of the early contributors as far as this particular data set is concerned, but you can see it's quite substantial. And so in looking at that, these are the kinds of issues that we have to consider when you're getting these data sets from different places around the world as far as their collection is concerned. Some of the features for different skin lesions are very complex. They might be related as far as they might have similarity for different types of skin lesion variations. They also might be very unique descriptors. One of the primary issues that we've seen, especially with an international data set collection, relates to the quality. And so this is one of the areas where we have multiple experts. We're trying to be able to annotate images for these different types of skin lesions and be able to use these multi-experts to be able to validate the data that we're getting. The other issue that we have is the quantity. Because of the prevalence of different types of skin lesions, we face the issue of, for example, malignant melanoma, relatively limited number of cases. If you go into cases like seborrheic keratosis, a benign lesion, lots of examples there. And so being able to, one, come up with data sets that accommodate both of those and be able to, again, translate that into training models or training tools and into AI techniques, that's a real challenge. And so here are some of the different kinds of features that we are currently working with the undergraduate students, with the three experts as far as annotating. And so we have developed a process to be able to look at these and be able to come up with a multi-expert validation type of process. And so, and I'm just highlighting quickly because I know I'm running out of time, as far as some of the different kinds of features that we look at. For me, as an engineer, I'm not as much on the science background. I love that a lot of the features are actually somewhat simplistic in their names. So globules and dots, network, very simple types of things. And I think that was done in part to help me be able to understand them a little better. So as I said, in finishing up, our goal is to be able to take AI and be able to integrate it as far as expert input at different levels, whether it's at the individual lesion feature or at the overall diagnostic level. And so this is really the emphasis of our research. And in finishing up, some things as far as some unique attributes about our particular research setup. We're using an NSF approach as far as student mentoring. We have a lot of pre-med students. We have students interested in AI. We give students the opportunity to be able to take leadership roles and be able to basically run with those. And then we are, as I said, it's been a very strong collaboration as far as being able to recruit students for this effort. We've been able to get students from Rolla High School in addition to undergraduates or pre-meds or students interested in AI from not only at S&T, Mizzou, South Florida, but from other places as well. So as far as my last slide, one extension that we are looking at is dermatohistopathology. We have done some work in the past in this area related to cervical cancers, so that's an area that we're looking to branch next. Thank you.
Okay, we've got our first question.
So the first one is, do you think this process could be scaled up to be used on mobile phones?
So as far as what's interesting is, so the short answer is yes, because the image quality on traditional cell phones has improved so greatly that it's actually, in some cases, difficult to tell whether the images have been captured through a dermoscope or captured locally, like through a cell phone. So the answer is yes, and we've seen that in some of the data sets that we've analyzed.
Yes. Oh, go right ahead.
So do you know, like, within your models and, like, kind of some of the imaging you're collecting, are you also collecting, like, images of stuff like moles, birthmarks, and other kind of, like, different skin conditions that people might have to kind of train those models that those aren't really images or, like, cancer
So
categories?
as far as answering your question, the ISIC archive is compiled by dermatologists from clinics with all the patient information discarded. But as far as, so there are 9 different types of skin lesions, to my understanding. In terms of there are benign lesions, there are malignant lesions, but in terms of non-skin cancer lesions, I do not believe that's part of the archive. However, when we look at the images that we see through that archive, there are a lot of artifacts that these images went through as far as when patients were seen in clinics. So you'll see ink marks, you'll see ruler marks, you'll see a variety of different artifacts that we are also having to deal with as far as the annotating.
Okay.
Thanks, Brandon.
So I love the fact that you get students involved early and help with this. I mean, I think that's key. So how do they find you, and what advice do you have for students to find a group to do research with?
So we've been very blessed, actually. The campus has really promoted this project well. I have seminars and different groups that I go and present on campus. Dr. Stecker, well, first of all, I should say we work through the pre-med committee quite closely. We also have a very active computational intelligence or AI interest on campus, and so we work through those promotions. Dr. Stecker is very good as far as promoting word of mouth, and that's where we get a lot of the out of UM system interest in being able to collaborate, just because we've had cases where Dr. Stecker has mentored so many pre-med students. They want that experience, they want the publications, and and it's really served us well.
And we got to get them hooked on science.
That's
Thank
right.
you.
That's right.
You have one?
I have another.
Yeah, come to
When
you.
clinicians upload images to the database, are they able to provide clinical context as well? And if so, are there any limitations with HIPAA?
So the short answer is yes, there is metadata. It's non-patient. So as far as all of the identifiers on the different images, the intent is those are all scrubbed prior to uploading any data set. So as far as HIPAA compliance, we're actually doing this. We actually were able to get an IRB exemption because there is no unique patient identifier. We went through the process anyway, just to be sure. But there is metadata that's available, things like age, demographics, other kinds of, that would be more non-image specific data that we can certainly integrate with as well. But I will say this, as far as the ISIC set is concerned, it's only partially available. So it's a very large database, and so part of our context is looking at taking a small set of images, coming up with annotations, and this is very much in line with the kinds of metadata that are available from some of the data that's been contributed to the ISIC archive.
I understand the limitation of the data set, but I wonder, do they have images of lesions on non-Caucasian skin types, skins of different colors, where they might be more difficult to diagnose?
Different parts of the world, so yes, different parts of and having had the opportunity just through recent validation work, there's a very wide range of locations on the body. It's very comprehensive.
Thank you.
You bet.
Okay, the last question's coming from me. You mentioned that you're having challenges overcoming the algorithms and AI. What are the biggest challenges to you developing those tools?
So, as I mentioned before, a lot of the AI algorithms are nonlinear in scope. So we do a lot of transfer learning related to deep learning models, but we also want to, within those deep learning models, be able to introduce the expert in the loop. So we take intermediate outputs from our deep learning models, and we're allowing the expert to go in and basically tweak the way the training occurs, and also the interpretation of the output, so that the expert is part of the learning process, so that we're not letting the algorithm converge on its own. We're trying to use the expert to guide where it's going in terms of the learning process, and then also trying to be able to use that to interpret the outputs that are related.
Great. All right. Joe Stanley, everybody. Thank you.